Radon 222 is an isotope of radon which undergoes a series of radioactive decays. Figure 7.1 is a diagram showing the proton number, atomic number, and nucleon number, mass number of nuclei involved in the series of decays. The point P represents a nucleus of radon 222. So it is here, radon 222. We can see that the nucleon number is 222 and the proton number is 86. Starting at P, a nucleus of radon 222 decays to Q, then from Q to R, and then from R to S, and then from S to T, and finally from T to U. State 2 points on figure 7.1 which represent the isotopes of the same element. So the isotopes are the ones which have same proton number but different nucleon number. So T and Q, they both have the proton number 84, but they have different nucleon number. Similarly, U and R, they have same proton number but different nucleon number. So we could write it as U and R. Different isotopes of the same element have different atomic compositions. State how the composition of their atoms is different. So there is only one difference, and it is they have different number of neutrons. Otherwise, the proton number and the number of electrons are same. A nucleus of radon 222 emits an alpha particle as it decays. The radioactive decay of a single nucleus is random. Explain what is meant by random radioactive decay of a nucleus. So randomness is that time when decay or emission of radiation would occur is not constant. Or we could also write the answer using the direction. The direction and the angle in which the decay occurs is not known. In nuclei notation, radon 222 is written like this. When a nucleus of radon emits an alpha particle, it decays to an isotope of polonium, PO. Complete the decay equation. So for the alpha, the details are it has a proton number of 2, and nucleon number of 4. For polonium, the proton number is going to decrease by 2, it would become 84, and the nucleon number is going to decrease by 4, so it would become 218. Now, the sum of nucleon numbers on the right hand side and on the left hand side should be equal. 222, 218 plus 4, 222. Similarly, proton numbers should be same, 86, and 84 plus 2, 86. State the name of the particle emitted by a nucleus of R decays to a nucleus of S. Now, R has a proton number of 82 and nucleon number of 214. S has the same nucleon number, but the proton number has increased by 1. So when a beta particle is emitted, this sort of change in the nucleus occurs. So the answer is beta particle. When beta particle is emitted, proton number increases by 1, but the nucleon number remains the same. Describe the change in the composition of a nucleus of R as it decays to the nucleus of S. S has 1 more proton and 1 less neutron, because a neutron is converted into a proton and electron when beta emission occurs. Then nucleus of R. So this is the difference. S has a greater number of proton and 1 lesser number of neutron.